Hello everyone, today's topic, representing and interpreting functions. Essential questions, how can we tell if a function is linear or nonlinear? How can we tell if a function is increasing, decreasing, or constant? And how can we describe and interpret graphs? Alright, let's get to it. First word here, linear. Any relationship that can be modeled with a line. You might see the word line right in there, linear, linear. And that's what we want to think of when dealing with these things. Let's start with graphs. Linear graphs form a straight line, like we just said. Here we have an example of a linear graph, this straight line, and this one that has curves in it is nonlinear. Moving on to tables. Linear tables have the same rate of change. I know these are a bit fuzzy, just how they downloaded to the program, but you can see it on your page. The inputs here go from 2 plus 2, 4, plus 2, 6, plus 2, 8. We see each of these changing by 2 along with this subtraction of 15. 50 to 35 to 20 to 5 minus 15 minus 15. As long as that relationship stays the same, even if the input skips numbers, that rate of change has to be the same. A nonlinear example has 1 to 1, and then if we add 3 to the 1 to get 4, we subtract 15 here to get to the 16, or add 15 more so. Then if we go 3 more to 7, this relationship, adding 33, does not stay the same. So that rate of change is different, therefore it's not linear. Looking at equations, linear equations have all variables with a power of 1, and they can be made to have the form y equals mx plus b. It doesn't always have to look like this, but just those variables x and y with powers of 1. For example, y equals 2x plus 5. Negative 3x minus 4y equals 12. Y equals 17, even though there's not an x. We still have this y equals 17. And 2/3 x equals 5 minus y. All have variables with the power of 1. Nonlinear relationships, you'll see things like this x squared, this fraction 1 over x, 1 over your variable, a square root, that radical symbol, square root of x minus 4, or even a variable in your exponent like this, y equals negative 3 to the x. These are all nonlinear. Using those as examples, see if you can label each of these graphs, tables, or equations as linear or nonlinear. Do that now. Okay, let's see how you did. This first one, we see a line that's definitely linear. This next graph with this curve most certainly is not a line, so that would be non-linear. Let's take a look at this table. We go from 0 to 1, and from 1 to 4 we see a adding of 3. So we go 1 to 4 is plus 3, plus 3. 4 to 7 is plus 3, and on the left here we have that plus 1, plus 1. It looks like that rate of change, at least from what we could see here, stays the same, so this is linear. Our table down here, on the other hand, goes from 0 to 2 to 4 to 6. That looks like plus 2, plus 2, plus 2. And then our output, our y's, looks like it starts with a plus 2. But then it jumps to an 8, which would give us a plus 6. And then from 8 to 18 is a plus 10. We see that rate of change being different from each input to output, so this is not linear. Our equation here is right in the form of y equals mx plus b with powers of 1 for our variable, so this is definitely linear. And lastly, we have this 2x squared. That's not a power of 1. Neither is this 8y squared, so this is not linear. If you made any errors, make those corrections now, and then flip your page over. So functions can be linear or nonlinear. They can also be increasing, decreasing, or constant. When it's going up from the left to the right, like a positive slope, we say that's increasing. When it's going downward, or a negative slope, we say decreasing. And a constant relationship stays the same, or a slope of 0. When the output is getting bigger, that's increasing. When the output is getting smaller, that's decreasing. And when we say something is constant, that means the output is staying the same. And you can see these match the graphs right above. So, which line segments in this graph down here are increasing, decreasing, or constant? We have line segment A, line segment B, line segment C, and line segment D. See if you can fill this out saying which ones are increasing, decreasing, or constant, and then we'll go over it together. Alright, for the increasing lines, those are going up from left to right. That looks like A and D. So increasing are segments A and D. Decreasing would mean going downward from left to right. It looks like from here to here, line segment C is decreasing. And lastly, constant means it's not changing. It has that slope of 0. And it looks like B is the only constant line segment there. So constant, we'll put B. Let's do one more type of example of analyzing these graphs. Jada fills her aquarium with water. The graph shows the height of the water in centimeters, that looks like our y-axis here, in the aquarium as a function of time in minutes. That's our x-axis right down here in time in minutes. So read these questions and see if you can answer based on this graph. Alright, let's take a look. Between what minutes was the water height increasing? Well, if I look for positive slopes, it looks like from 0 to 2 is one of those intervals. And then also from 3 to 5, it looks like it's increasing even faster. So between 0 and 2 and 3 and 5. At what time in minutes was the tank fullest? Well, that would be the highest point of the graph, which looks like a height of 30 centimeters, and that looks like it's at 5 minutes. Between what minutes was the water height constant? So we're looking for a slope of 0. I see one here between 2 and 3, it kind of flattens off. And then also between 7 and, we'll just end it at this graph here, 10. So between 2 and 3 and 7 and 10. Between what minutes was the water height decreasing? That's a negative slope. Well, it looks like this is the only point when that height is getting smaller or decreasing, and that's between 5 and 7. So there you have it. Take a few minutes, answer your essential questions in 3 to 5 sentences down here at the bottom. I hope this video was helpful.